Hi, and welcome to the Unreal Engine News and Community Spotlight. A brief update on our GitHub access. We recently implemented OAuth functionality to the GitHub Epic Games account linkage process to improve security and user experience with those services. Unconnected users will now need to log into GitHub with validated accounts in order to link them. If you've already connected your accounts, you're all set. If you haven't yet, we've outlined the new process in our blog post, though you'll be prompted all the way through if you're looking to get started with Source. Next up, Nathan Menifee, one of 4 developers that make up New Zealand-based game studio Lunar Rooster, walked us through the history of Skynoon, their Wild Western competitive multiplayer shooter where players have no health and guns don't deal damage. Instead, all the weapons and abilities are tailored towards dealing knockback to your opponents, as that's the only way to eliminate them, by sending them flying off the floating maps. You'll use a permanent grappling hook ability, a jetpack, a lasso, and more. So while students together, they used Unreal Engine to rapidly prototype a number of projects, taking advantage of Greybox BSPs to outline their levels, and ultimately landed on what was then Skyforce. Recognizing its unique gameplay elements and colorful art style, they continued development and ran a successful Steam Greenlight campaign. Skynoon will be rolling out in early access on Steam for additional feedback on balance and maps, with a full release anticipated later this year. Learn more about their development process and check out their trailer on the blog Skynoon, Reimagining the Wild West into a First-Person Action Brawler. So we all know that virtual reality is an effective and powerful tool when designing memorable interactions that stick with individuals long after the experience is over, and for auto manufacturers. VR offers the perfect mix of total immersion and customizability that only real-time technology can deliver. Animec, specialists in creating visualization tools to help clients evaluate their brands, recently caught the eye of Volkswagen Sweden, who commissioned the team to build a VR car configurator experience to help showcase its new Arteon model. In need of a way to show their new model to potential customers without the models actually available in dealerships, the custom-tailored real-time VR configurator let customers get up close and personal with the Arteon in ways that wouldn't have otherwise been possible without the physical models available. The unique experience let consumers don VR goggles in order to get an immersive, photorealistic look at the interior and exterior from every angle in a fully customizable and interactive way. Swapping features, colors, and other important details in real time let users get a feel for how their custom spec options would look. Additionally, the experience tied into the central business systems allowed dealers to easily produce a price quote based on a user's customizations. It proved a powerfully effective tool for driving pre-orders, and it's possible this setup could soon become the new norm for dealerships. Follow up on the blog to see a video of their configurator in action. So it's time for our weekly Karma Earners. These folks have been aiding their fellow community members, answering questions, and solving problems. So thank you so much to Thompson N13, Shadow River, Nebula Games Inc., T. Sumisaki, Harry High Def, Mighty Enigma, Dotcam, Fill Me Up, The Hiva, and Think01. So our first community spotlight is Keeper. Keeper is a demo made by 2 student developers as part of their senior thesis project. In Keeper, you take on the role of a lighthouse keeper. So this is a world that is a little like BioShock, a little bit Firewatch. They're also inspired by What Remains of Edith Finch. The ambient sounds and the music playing on the radio tied together with the spectacular graphic aesthetic bring this beautiful game together. And as the keeper, you're tasked with ensuring the lighthouse stays functioning during the day and at night, protecting the boats from crossing or colliding with other spirits in the water in almost a missile command kind of way. So in addition to just creating a fantastic project, Keeper has been nominated in the Rookies for Game of the Year in the PC console category. They also posted an extensive write-up for how students build games that was featured on 80 level. It's a great read, and I encourage you to follow that up after the show. Our second community spotlight is a project called The Watchmaker. So these folks were awarded an Unreal Dev Grant, which and the project itself just released last week. So congrats to the team. It's a puzzle action-adventure game set in a steampunk world where time has gone mad. The sabotage of your clock tower has made you age quickly. If you reach age 90, you'll die. So only repairing the clock tower can save your life. The main character, Alexander, seems to be dealing with some sort of existential crisis, but the game looks absolutely stunning, and the combination of steampunk with the lighting and shadowing really gets us all excited to give this game a shot. So, great work by that team.
For a plant which lacks reasoning, it does not exist. It just grows, ages, and eventually dies. That is,
And finally this week, the last project is a short film made in Unreal Engine by a team of just 6 people in 15 weeks. This was done as their final project for a university project, and we think they've really done a great job capturing the science fiction atmosphere while adding suspense and mystery. When concluded, we just really were driven to know what happened next. They did an incredible job with the visual storytelling, and we're excited to see more from these folks. All right, thank you to all the folks on our Community Spotlight. You're doing a fantastic work, and can't wait to see you next week. Thanks for joining. Hi, and welcome to our Unreal Engine live stream. I'm your host, Amanda Bott. With me, I have Aaron McLeran, lead audio programmer, Zach Bilica, audio director, and Tim Slager, other community manager.
Hi, everybody.
Thanks for joining us, and we're really excited to have you all back. Before we dive into all the audio goodness, we will be giving some closed beta keys for Sky Noon away today. We're going to be dropping those in chat. I think their closed beta closes tomorrow, so if you're going to jump in and try it out, now's your chance.
If tomorrow's Friday, then yeah.
Yes, it is Friday.
Okay,
Tomorrow.
yes, then tomorrow. Good days. Days go.
But yeah, so would you like to give a brief overview of what you're discussing?
So my name is Aaron, and I am the lead audio programmer at Epic. And joining me on the stream today is Zach Bilica, who has a new title.
I guess I'm now director of audio production, but still with the audio department
He's
and
an
doing all
audio
kinds of fun
director.
stuff.
Snuck it in on.
Yeah.
So I'm normally based in Seattle, and so it was a fun opportunity while I'm in town here in HQ to be able to come on and do a live stream about some of the audio engine features that we've been working on, kind of walk through some demonstrations of that, talk about some of the basic features for people that are new to audio in UE4. Maybe you've used middleware, and maybe you've used UE4 but with third-party middleware, and kind of are curious how audio works in UE4. And we'll go through some basic features, and then I'll take a tour through some more advanced stuff. It's going to be pretty quick. We're not going to go in extreme depth. It'll just be to give you a taste of some of the stuff. And then hopefully, this may be a little bit boring. It depends on how the stream goes. But I have, I have basically an architecture diagram of the actual audio engine. And we'll kind of walk through sort of how sound is born in the game engine, and how things happen and actually make it out to actually playing audio, and sort of how that process works. So I think it's useful to have the sort of in your mind the concept of how the actual engine works, to understand what's going on with audio and why certain features are the way they are, and that kind of a thing. And while I'm going through all this stuff, Zach is going to be in the peanut gallery and either criticize me or be like, yeah, we use that. My hope is Zach is deep into audio implementation on Fortnite, and we're leading the audio team on that end. So my hope is to maybe give some context to how some of these features might work, and how Zach might use some of these things in real-world applications. I think that'd be kind of an interesting topic to discuss. And then maybe we can talk about where there are some things that are maybe not the greatest experience, and where we can take things and sort of improvise and see where the conversation goes, and get some feedback from you guys out in the world. We have a staff here that is going to feed us your heckling, so heckle away. They'll try to convey your anger and astonishment and wonder through your texts.
Sounds like a good time.
Yeah.
Sounds like a good time.
So I put together this project here. This is all 419 stuff. it's we can post it. It's going to be sort of a playground for things. If you notice, I have it organized over here on the left with, basic features and then advanced features, and then in this sort of subfolder here, I've got sort of a list here. This is supposed to keep me sort of in order of the things I want to show, but you can see in this folder, there's literally nothing here. It's just to remind me that, at this point, I want to do some demonstrations, importing and how to do basic stuff. So
We don't need notes. We have
yeah,
Unreal
exactly.
Engine.
I just use folders as notes. So anyways, so there's no new map here. Let's make a new map here, just to have nothing in the background. So basically, one of the, I think, exciting things about UE4 and audio, and so I've been at Epic for 3 years, and when I was first learning how, the various feature sets that exist inside UE4, and I was trying to learn it myself, I was struck by how simple and pure just the basic process of getting just a sound to play in the game. And I always like to like kind of demo this first, because I think it has a kind of it resonates with me as a a content person. I have a background in sound design, that it's really cool to just there's no overhead. So for example, I've got a folder here of just a bunch of sounds. I have raw assets on disk. I've split it in stereo, mono, but let's just take some mono sounds. And if I want to import this into the game, I just literally can, double click and play it in Windows.
Thanks, Windows.
I can just drag it into the content browser, and it imports all my assets in one drag. And immediately, you can see it highlights it as sort of a dirty asset. So if I wanted to save all these imports, I just do Control S, and I can right away start going through and previewing the assets in the browser, so you can see what they sound like. And you can even see a little visual thumbnail on sort of what that looks like. We have a lot of ideas on how to improve audio behavior in the content browser. I think it'd be really cool that instead of this stop and play button, it would be cool to actually animate a waveform and sort of be a little bit more active.
Yep, well, I think at some point to try to get spectral information too.
Spectral information. It'd be cool to be able to preview both the time domain and the spectral output.
Make like a little piano just
Or-
from the asset.
You could.
We
Yeah.
should just add pianos everywhere
general,
we
yeah.
can in the editor.
You can never have enough pianos.
Yeah. So this is in the content browser. This thing down here is the content browser. And if I wanted to play at my level, I could just drag it off of here into that. To me, that's magic, that I could just drag it from the content browser into the world.
You can literally move sound
I can literally move sound and mountains. I just clicked build by accident. That's not-
and build mountains.
I could build mountains. So then when I push play, you'll hear it. Nothing exciting, but in terms of the minimized implementation path, it's pretty exciting. For me, it is. And if you'll see here, I've got a whole bunch of other stuff. But in terms of the basics of audio importing and playing in the world, it's pretty great. If you double click these assets, you'll get a huge list of sort of metadata about the sound. Sort of for example, down here you can see the number of channels, the sample rate, the duration of the sound file, where it lived on disk. We actually even support re-importing, so it's really easy for you to iterate on your assets without having to constantly figure out where it is. It'll just re-import. There's a whole bunch of stuff. We don't have time, obviously, on this stream to go through everything, but there's a lot of features. This particular object that's created here is in terms of sort of game engine architecture, a derived object from a sort of base class that we call sound base. So a lot of the APIs that I'm going to talk to you about actually work with this, as well as other type of objects. So if you can, I'll show you how to play a sound. It'll actually work with this as well as more complex objects, which I think is actually another really cool thing about the UE4 pathway. So I just wanted to show that for here, how you do importing. Importing has a couple of caveats, certain formats it supports. That's something we want to expand on, let UE4 eat every possible sound asset that you can imagine of all different format types. I think that would be a great thing. But just to show you, I'm going to show you what a stereo file would look like as a
So you can see sound.
Yep. So here you can see that it's 2 channels of audio. So it's stereo versions. But anyway, so that's importing and playback. So the next thing I wanted to show is spatialization. I think that's the sort of next step up on just playing sounds. Let's attenuate it and spatialize it around us, in 3 dimensions. So I made a really, really simple map here. I just basically did one step up from what we did before. Is I imported a sound. This is just a looping engine sound. By the way, if you can make sounds looping by just checking this box here, and it will constantly loop. So I just drag this into the world, and that's this guy right here. Technically, when you drag an asset from the content browser into the world, that becomes what's called an ambient actor, and it just is located in space and just plays when the level plays. And there's some sort of tricks you can do with it. In this case,
Does it play within a sphere?
yeah,
So
so
if
that's
you're
what I'm
outside
going
of
to
that-
show here is that by default it just plays the sound as 2D, what we call in game audio 2D.
There's space everywhere.
Yeah, 2D just means that we're not making it 3D.
Gotcha.
Although counterintuitively 2D sounds can be 3D, I mean, depending on the actual content of the audio signal. Hellblade, which is a native UE4 game, actually used that to extreme quality advantage, where they did a lot of really cool 3D audio effects with just 2D sound playback.
That's awesome.
So anyways, so with this, how this is working is I've made a new asset here. This is attenuation. If you go to sounds here, this is sort of the right click, making new assets. If you go to sounds, you'll see a whole bunch of different audio related sounds. What I made here is called sound attenuation. It's counterintuitive to talk about attenuation. This could be called sound spatialization, but it's kind of a bucket of a lot of different things related to how you attenuate a sound. And so that's this asset right here. If I double click it, you'll see tons of yet more audio parameters that we don't have time to go in extreme depth with. But recently we organized this to make it a little bit easier to understand different things that are related. So the things I'm going to talk about here are this section here, which is attenuation distance. What that means is that the sound will get quieter or louder as a function of distance. And so this, defines what function you want to apply. So whoops, I'm closing it. Like this would be like natural sound. A natural sound obeys inverse square law, like of power. And I used to teach physics. And so I think about things in a lot of physics
Most
stuff.
people don't think of
Yeah,
inverse
exactly.
square.
Exactly.
Normal-
No one, in my mind, I'm like, the equation is, but anyway, so this is trying to emulate a more natural fall off. Real world sounds don't fall off linearly.
They
And so,
just drop.
yeah, and so counterintuitively, this can cause you to have weird perceptual issues with distance attenuation in games.
Yeah,
I don't know.
linear feels closer. It's
Yep.
easier to conceptualize.
Yes.
Logarithmic is a little closer to natural
Yeah.
sound, but it has problems with it being too quiet for too long. And
Yep.
so, the natural sound, or also actually, I was going to say, you can do custom curves
Yes.
as well, which is
If you do this, you can actually draw your curve right in here.
Do you have examples of sounds that you would hear in the real world that kind of follow these?
actually I do actually, and
That's a good
so
question.
Fortnite. So and actually, you saw that Aaron had some.
Oh.
As part of the, we use custom curves
Yeah.
as well as natural logarithmic curves. But Aaron had created a library, or basically a file for a preset of sound attenuation. So for Fortnite, we have a whole bunch of presets that we've made. So we know that hey, guns sound this way, different grenades sound this way.
Yeah.
And a great setup we have is for all of our guns. We have close, medium, and very distant versions of all guns.
Oh, you meant Seth.
Yes.
Seth made a library.
Yeah, well, Seth made a library,
Yeah.
and,
Yeah.
and we continue to say the world as well.
Yeah.
And yeah, so what we do is we have I think for the closest in gun, you want to hear it, you're firing it. It's the most big sound there is. It's stereo, but it has a relatively rapid fall off. I think we use just a simple logarithmic style. I think it's custom, but logarithmic style fall away. But what's interesting is that the medium and distant versions of the sounds have fall offs that actually they're sort of like donut holes. They're actually quiet close to the player and get louder as you go away.
Yeah.
Because you want, and then
Yep.
all three sounds play at
Yeah.
once, so they overlap.
Yeah, I'll talk about sound cues in a second as a way to bundle the idea of a sound into a more complex object.
Yep.
So he's saying is that he's actually spoofing, making something sound more realistic by making a
you're
bizarre curve, right?
Here. So
Yeah.
it's-
So like
You
something
have
near
a peak at the distance, right?
Exactly. So you might have a meta object that is composed of multiple layers, where one is like sound designed to be the nearby sound.
Right.
So it has a really exponential nearby curve. But then there's something that's sound designed to be better at medium, so it looks more like this. So nearby it's quiet, and then it's medium, then it goes back
So
to
it's
quiet.
very parabolic. in
Yeah,
that
and
sense.
then something far away might be like,
Right.
and it'll be like quiet nearby and then get louder. And so you can layer these together like this to get really more complicated sounds.
Yep, it's sort of an advanced concept, but it's
Yeah.
it's something that a way you can use distance attenuation to do very advanced features.
Yes,
with just-
yeah.
just with
As a
camera.
very basic thing, it's just like things get quieter as a function of distance. And so that's what I'm going to show here is the basic stuff.
Gotcha.
So if I set natural sound, this guy's like, hey, this is the dB attenuation at max. This is like the decibel attenuation when you're at the max radius. And then you can actually set the max radius here. So you basically just say, hey, this is the radius at which something is near, and here's the radius at which something's far. And then this is the other section I want to talk about. So this is actually subtle, but a really cool feature of UE4 in that distance attenuation is orthogonal or independent of spatialization. Many engines conflate the two, where you're like, oh, if you want 3D audio, it's assumed that you want three-dimensional panning and attenuation always together. But it's kind of a cool thing that it's orthogonal here, because there's a lot of things where you actually want to play a 2D sound. It's not 3D, but you want it to get quieter versus distance. Yeah. So that's another thing that Hellblade, when I'm playing it, they use that a lot, because I said they were doing clever tricks with 2D sounds, but they made it feel more 3D by getting it quieter as you walk away from a source
So
or
somebody's
whatever.
turning down the volume.
Yeah,
does really
exactly.
well, yeah.
But it's still not panning. So anyways, they're two different things, and you kind of have to enable them. It kind of defaults to on when you create this, because it is most of the time you're going to link attenuation with spatialization. But so anyways, then in this spatialization here, we've got two different modes of panning. I'm going to talk about binaural as like literally the last thing for advanced stuff, but it defaults to panning. The difference between panning and binaural is panning is like sort of a more, it's an older tech, but it's, you know, tried and true, and it's essentially like you would, you know, if you have a DAW, it's like the pan knob or a stereo panning knob, and basically it allows you to automatically pan across your speaker set. So if it's stereo, it just pans left and right based on the position of the source relative to the listener. If you have a surround sound system, it'll automatically pan through your surround sound system relative to the listener. So if I like turn the angle of where the listener is, the sound will automatically pan to the right or left based off of that. And then there's some other advanced stuff, like we support 3D stereo spatialization. What that means is you have a stereo source that is playing in space, and there's sort of a parameter on how you want to define the left and right channels of that stereo sound in space, and that's what this parameter is. So again, we don't have, there's a lot of stuff with this. We don't have time to go into detail. But
Just a quick
yeah,
example
sure.
might be like you put a piece of stereo music in the world and you just want the music to come up in a certain area. So
Yeah.
you could turn on attenuation,
Yep.
but then you could either turn off spatialization and it would just get louder
Yep.
as you got to that space,
Yep.
or you could leave on enable spatialization and it would spatialize, but you could use the non-spatialized radius
Yep.
when you're close enough to the music where you don't want it to pan around
Yeah.
anymore.
Yeah. So I didn't mention non-spatialized radius. So non-spatialized radius is basically a trick to kind of blend to a 2D. So it can become 3D when you walk away. When you get nearby, it'll get more 2D-ish.
So it's like you're walking into the room where the sound
Yeah.
is, as
Yeah, and
opposed
then
to
so
hearing
it's
it
like
off in the distance.
Exactly. So imagine like a boombox playing some stereo
Right.
music, and it's like over there, and it sounds definitely over there, and you walk up to it, and it'll like envelop
Right.
you in total stereo.
Now suddenly I'm surrounded by Grandmaster Flash.
Exactly.
Yeah, exactly. Yeah, totally. Yeah.
And having it not pan means it won't spin around when you're
Right.
inside there.
Yes.
Unless
Yeah.
the boombox is on like a Lazy Susan or something.
Yeah,
Yep.
yeah. Game audio has this issue. This is another thing that non-spatialized radius helps with. Is I forget what I've called it in the past, but basically like vector, like what's that called? Basically, it's near field panning. If something will be right in front of you and then it passes over, it'll go like and it'll
Like a
flip
bullet
instantly.
flying by.
Kind of. It's just, if you imagine like the whole way panning works is you do a vector from the listener to the source.
Right.
And you imagine if that source is coming at you, you're pointing, and it's panning on your surround sound
right.
speakers in front of you. And then as the source passes you, it instantly flips from front to back.
Instead of the cone
Instead of
being
going
this
like-
way, it's suddenly
Yeah, smoothly blending.
it's chasing the sound as opposed to.
Yeah, and it actually can cause a pop, like an actual discontinuity in the signals.
Oh,
It happens
interesting.
it's happened so
Yeah.
fast.
And
And this is a side effect also of cameras in games.
Yes,
So
and
your
cameras is-
Your player is smooth moving, but your camera can move any speed. So
That's right. And so this kind of helps with that too, where you're like, if the source is right on top of you, just blend it to all the speakers so that you avoid that like instantaneous pop of front to back,
Gotcha.
that kind of a thing.
So if you're getting that pop in game, you suggest. using this as a feature.
Play with the non-spatialized radius. Yeah.
Yeah.
So just showing you this. Basically, all I did was drag this guy in the world. If you see the sound down here, and then I just dragged this attenuation setting over to here. It's like a slot. A lot of UE4 works by asset slotting into things. And if you wanted to override, if you just wanted to make a one-off, like not make an asset and just do it right here, you click this button, and then you would just say, here, now all of these parameters down here work with this override.
yeah, just for that actor.
Just for that actor, yeah. I recommend, I've toyed with getting rid of this override because I think it causes a lot of confusion. But there's tons of backwards compatibility issues, and a lot of things have evolved slowly over time in UE4, as you could imagine. I mean, it's UE1, 2, 3,
Right.
4. There's a lot of stuff, in terms of like, why is it this way? It's because it was someone decided that 15 years ago. and we have a lot of licensees, so it's hard to change.
On a very quick side
Yeah.
tangent, we actually just celebrated 20 years of Unreal 2 days ago. So
Yeah.
I mean, this is the evolution of the technology.
It's-
It's insane.
Yep. So anyways, I'll do this demo so you can see that it gets louder and more quiet based on where you are. I just like sort of poor man visualized it by just dragging a sphere next to the sound here. But that's all it is just, you know,
It's kind of what I hear when my wife yells at me.
yeah. So just to play with it a little bit. I'm in my zone, man. Sorry, I can't react to your jokes. But that was a good joke. Right? But anyways, just play with this a little bit. One of the cool things I think is kind of neat is this attenuation air absorption. So you just turn this on. And what this does is basically apply a filter based on distance. Like a filter like makes it go like, you know, kind of a sound. And so the way that gets set up is, so my distance radius here is 4 and 3,600 or whatever. Let's add that. So basically this is the range at which filtering starts happening. And this is the range at which filtering stops happening. It kind of like defines the min and max points in terms of distance from the listener. So let's make this like 2,000. So it'll be severe. Now you have like, what's the filter for the low pass filter? Low pass is the thing that goes like that. It's harder to do a high pass filter like. There you go. But anyway, so low pass. So we want it to be full band. This is at 20,000 hertz right here, at near. And then we want it. Let's make it obvious and severe. Let's make it go to like 500 hertz. So it'll go, you know. And then the high pass is kind of counterintuitive. I added this recently for the new audio engine. High pass is really valuable for distance attenuation because there's two factors that go on with getting something to sound realistic as it gets further away. This is kind of analogous in graphics to sort of like dimming light, you know, gets more diffuse because light is going through the atmosphere, so it's getting scattered. And so the low pass filter represents the scattering effect, where sounds are going through the atmosphere and they get scattered, and only the low frequency sounds make it through, just like, the
Blue light.
blue sky. So the high pass filter emulates the fact that human hearing is non-uniform in terms of volume perception and frequency. So it's called the Fletcher-Munson curve. I should have had a curve up, but basically we don't hear lower frequencies as easily as higher frequencies.
Isn't that a youth thing too? Like as you're younger, you'll hear.
That's a high frequency thing. Yeah,
is that,
but
okay.
yeah, we should have like a youth simulation button here,
Yeah.
like to boost high end, so that you can imagine like this is
Actually,
what
age verification.
Yeah, this is how younger people hear things. You know, just like
Yeah. Is that so? Slight tangent. Is the whole Yanni Laurel thing? Is that kind of the same?
Actually, it is kind of related because we actually did you guys analyze it too? Like over in Seattle, we broke out our analyzers. So my theory on it is that the difference is youth is old because the younger people are hearing higher frequency stuff,
Which
is how you're hearing the more yeah parts of it.
Okay.
To me, I just hear Laurel like no matter what I could do.
Either one.
Yeah, there was a
You have better hearing than
website
me.
that had a slider that you could go back and forth. So.
So anyways, so what this is doing is simulating the fact that as sound attenuates versus distance, the lower frequencies will be perceived to be affected faster. Like, so sound volume falls off as a inverse square law. You know, that means like 1 over r squared, where r is the distance, you know. So it falls off quickly, but the lower frequencies will be perceived to fall off faster. So essentially, this is doing that, and it's cool. Typically, the curves look like, you know, if you're trying to make it sound realistic, low-pass filters fall off faster, and high-pass thing comes up a lot slower. So distance attenuation resembles a kind of band pass, is what we call it in audio.
And is the point where those two meet the point in which it's the closest to you?
That'd be cool if they actually did. Typically, it doesn't meet, but like, and it just disappears to nothing. Anyways, so let's just make this like 1,000 or something, so you can hear the effect. So let's try this. So if I do this, it's mixing with volume attenuation too. So if I actually make the volume attenuation a little bit longer, you'll hear it probably better. You can hear it kind of go.
Yeah.
Sounds a lot more realistic.
That's neat.
I'm playing with some really cool Doppler features so that when we do this, it'll go, you know, like have like a realistic Doppler. Anyways, so that's attenuation. We could go on forever. So next thing I want to talk about is sound cues. Sound cues are a really old concept in UE4, but we want to get off of just playing a sound like this, just playing a sound. Let's play a meta sound or a meta object. So what I did was I prepared these guys, which are kind of related sounds. Let's say we wanted to easily randomize which one we did and maybe do some more complicated stuff. So I'm going to make what's called a sound cue. A sound cue, let's just say demo cue. Whoops, got a caps key. So a sound cue, if you double click it, it opens up yet another graph editor in UE4 if you haven't looked at these. I want to say sound cues were one of the first graph editors.
First, yes.
Is it the first or one of the first?
I don't know if it's the first, but it's
It's definitely
old.
old. This predates Blueprint. And so, on the right here is this palette of nodes that are possible. I mean, you just drag it off and you can mess with it. But it's kind of a pain. There's some utilities. A lot of sound designers I found don't know about this. Is if you select the assets that you want to add to it. I'm going to just make a sound cue. Let's say I want to just randomly pick from these 4. I can select these and I right click and there's a whole bunch of utilities. I have an idea. We want to add some more things to this. But if I just do random, then it automatically hooks up a node to random. I can just connect the output here.
Yep, I use that one every day.
Yeah, it's very useful. And now I've got. So it'll randomly pick and it animates like blueprints do, which is great. But you can do more stuff. Let's say we wanted to randomly pick pitch and volume, which is a very common thing that sound designers want to do. And you could. The nice thing about this is that you could not have to do randomized pitch and volume if you wanted, but you could also do it. Let's make it a little bit kind of funny and severe here.
So multipliers, minimum and maximum there.
Yep. So here we can say we're going to randomize the pitch, so it's pitched up and down. It's a way to get more variation from a handful of things. So, and then what's cool down here is that this output has a similar kind of details panel that you noticed that over here, let's put this back. So this is that sound wave. It has a similar set of stuff. That's because both of these guys are inheriting from the same base class object. So a lot of the stuff that you might have used and learned from this object that we talked about also apply to this object. So that means attenuation settings and all the stuff that.
And they're all private variables for each.
Yeah.
Okay.
Yeah, exactly. Yeah. And so, anyway, so sound cues are really powerful. One of the benefits that they have is they allow sound designers in some way to work a little bit like an over the fence method. So a gameplay person might add a hook to a sound cue and then not actually do anything in the sound cue, but it's like a sort of stub. Right. And then a sound designer can go later and just load that sound cue up and start adding their sound design and complexity there.
We often prototype like that. We say, hey, we need to start a loop and a stop sound. We'll make 3 dummy sound cues, and then they can hook those up in blueprints, and we can work in the cues while they work in the blueprints.
Yeah. And if you want to see the complexity of sound cues and how insane they can get, you should just Google UE4 sound cue graph insanity. I'm sure that'll show up something. But there's a lot of stuff that can happen.
UE4.
I am often fixing bugs in these things because they expose edge cases. One of the other benefits of this, and it's subtle, is that sound cues are actually executed on the audio thread. And so sometimes the timing is actually a little bit better that you'll get on in a sound cue than you will if you're doing all your timing stuff off the game thread.
Especially with delay lines.
Yeah,
Like that,
you might be doing some kind of delaying and timing kind of a thing in here. The downside is it doesn't have any of the power that blueprints have in terms of debugging, variables, math, all that kind of stuff. So there's some thought about how to take sound cues into the future, and almost all of those things lead to just making sound cues like Blueprint. So we're playing with the idea, early experimentation. I'm not promising anything, but we have this idea of potentially trying to figure out how to get blueprints to run on the audio thread and bring an audio thread blueprint. But it's so that we can get the kind of power that we have in sound cues while also marrying it with the power that we love and know in blueprints. And
Yeah, I would look forward to that because I said making custom math. I said
yeah.
We have fixed arrays here, like random arrays or concatenators, where you could make any kind of array you wanted, and variables and branching would be awesome.
Blueprints are really powerful for audio. I have that as a section coming up, but you can't deny that sound cues are really powerful. So you can basically do the things that the spatialization with the sound cue. So let's talk about blueprints. So how does sound work in blueprints? So I just made literally an empty blueprint here, so I didn't have to spend time making it. But let's just walk through the basics of audio and blueprints. there's the best way to think about audio blueprints is there's a lot of things you can do with audio blueprints, but there's two main things. Like the one thing you would do is play a sound. Like from blueprint, I want to do something like play a sound. So let's add from event begin play here. Let's just type play sound. Oh, look at that. So there's two flavors of play sound, or ways of playing sound, I should say. The first flavor is what I would call the play sound API. There's play sound 2D and play sound at location. I honestly feel like I would like to just deprecate play sound 2D because playing a sound without a attenuation setting plays it as 2D. So what's the point? But anyways, if you do this, you'll see these two API calls here. We've kind of hidden complexity by default in some of these. You can see this guy gets pretty complicated. Basically, you just select the asset that you want to play, and just like the power of UE4, things just show up that are capable of being put into this slot. So you can start typing like the sound you want. Similarly, you can create a variable. Let's say you wanted at runtime, wanted to decide what sound you wanted to play based on some game logic. So you could say here, back when I was talking about sound base, this is important in blueprints because it actually is a variable type that you can add in blueprint. So if you wanted to make your blueprint generic and not just play sound cues,
right,
but potentially play sound waves,
waves, or
dialogue waves, or in the future there might be a new type of sound object that might exist that I'll subclass off of sound base. So you're like future-proof your blueprint, and you can just say like, oh, here's a sound type.
Yep.
And then over here you could go over here and see like the sound I want to play, and the same thing shows up. So let's just do my, I don't know what this is.
Big robot footstep?
Yeah, probably. I made it earlier today.
Yep.
Yeah, let's just play that. So then I've made that as default. I could make it a public variable so we could customize it outside the blueprint. For new sound people who don't know blueprints, go study some blueprint tutorials. It's really awesome. Yep. And then you can go over here and just plug it in, play your sound. You could also play it on this guy. So the difference between play sound 2D and play sound at location is that play sound at location requires you to specify a location to play it at. We also support sound orientations. This correlates with another thing, which is a attenuation type, which I didn't go through. There's different kind of curves. Right. One of them is like a cone. So you can hear audio only in a given direction. What is that direction? It's defined by this rotation. So you could actually, we'd use this in Paragon a lot, I remember, where we had tons of these little robots that were like talking and stuff like that.
Right.
But one method of cutting down on the amount of audio that's trying to play is to like sort of make it more directed.
Right.
So you'd only hear audio from things that were like facing you.
So its fall off is literally, it's a linear fall off.
Yeah, wherever it's facing, so we get the pawn, wherever the pawn was facing, we get that rotation information, just slide it right in.
Gotcha. Now, can you do something similar with your random sounds that you blueprinted earlier?
Yeah, well that's what this guy is, this sound here is one of those random sounds.
Oh, okay.
So that would this is the random sound, and it's going to play here. So if I just demo that to you.
So every time you play, it's going to be something different?
Let's just put this on a set timer by event loop. And then let's do this. Add custom event, like play, robot.
Yep.
And so what I'm going to do here is rather than I'm on this, I'm going to do this. And then I'm going to do this.
And to folks who have done Blueprint for a while, this is the new preferred way of doing it, other than doing it on tick. So this is the right way to do it.
So using that event timer?
Yeah, event timer. And
so I'm going to make this just a looping thing, so every second it's just going to like play robot footstep every second. This is better for timing. It's better performant, this method.
Yep.
It's a little bit more flexible. You can have this guy at the end here trigger this and then change the time here.
Right.
So that it can be variable timing. So it's like...
So it doesn't...
So it doesn't have to be constant. For sake of simplicity, I'm just going to play this sound, and then I got to drag it into the world. Go back to Blueprint. Where's my basic features? I sing to myself a lot.
That's perfectly okay. You should, in fact, the rest of the stream should be sing-song.
I think so.
Is this okay? I'm still on the spatialization map. Let's don't save this stuff.
I have a Hamilton version of the...
Yeah.
I could just... And now we put the blueprint in the level. So then you can see here...
I was just looping that sound.
Yeah. So it's playing this sort of randomized sound cue. Just, it's 2D.
Right.
And of course you have the 3D version. So the other flavor of play sound calls, so like I said, there's play sound. The other one is spawn sound. And I want to just briefly talk about stuff. I get asked this all the time. this issue in Blueprints. So we have spawn sound 2D, spawn sound at location, and spawn sound attached. So the difference is play sound just plays the sound without any means of controlling the sound after it started playing. There's no handle to it back in the Blueprint.
Yep,
So
set and forget. So it's like,
yeah, it's just a fire and forget or set and forget, and it's more performant, and it's great if you don't give you don't care about what happens to the sound after it starts playing. It's horrible for things like loops. Like if you play a loop, you should not just use a play sound call because that loop is just going to live in the world forever.
yeah, there'll be very few ways to stop it.
Yeah, and that's actually called an orphaned loop, and it's a problem. You'll be playing a game,
loop.
and it happens all the time.
Right.
Like, you'll be playing a game, and all of a sudden this thing just seems sitting in the world, like whoa, 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 and you're like, what the heck, And that's an orphaned loop typically. Is like either that happens in UE4 where somebody tries to play one of these with the handle, but the thing that has the handle that's supposed to destroy and also destroy the handle or audio component doesn't ever get destroyed, and things get looped and. There's a whole bunch of code
forgotten.
to like spew out warnings like, hey, this
Yeah.
sound is orphaned.
Yeah, you'll get log spam all over the place.
Yeah.
So.
Poor loop.
And there's a debate on whether or not you should just kill a sound if it's an orphan, if you can detect that it's orphan and just stop it. One of the reasons you might not want to do that is that it could be a legitimate use case to just have a loop in the world and
Right.
let it play forever. And I don't care.
Like a water wheel.
Exactly.
Water wheel or
Exactly.
wind or
Yeah.
something like that. Yeah, you can just
Yeah.
let it go.
Yeah.
So, anyways, so that's what these guys are, and what these guys return are audio components. So let's if I were to just promote this to a variable, you'd see the type here is a audio component. So a lot of people, I do a lot of support. Audio components are really powerful. You can, with an audio component, do really powerful things like set volume multiplier. You can do all kinds of things with the sound live. You can set its pitch, you can set its volume, you can move it around in space.
You can change the sound playing.
You can change the sound which is playing. But what it isn't is a lot of people get confused because if they set a sound and then play it and then are surprised when it stops the previous sound playing on the audio component. The best way to think about audio components is a handle to a single playing sound. And by that I mean like a sound base, a single playing sound base. And so if you want to play multiple sounds with audio components, you have to use multiple audio components.
Making a playlist effectively.
Yeah, and then controlling them independently. You have to make an array of audio components and move them around independently. You have to understand this sort of one-to-one relationship.
Yep.
But,
And then, so for my own thinking, the way I use
Yeah.
stuff is that if you know you have a blueprint that's always going to need a sound, you can
Yeah.
add audio component that's always there.
yeah, you can just go up here and say audio.
Yep, and
That's-
that'll always, now it'll cost to be there, but it's
Yes.
useful sometimes for like
Yeah.
something that's always there, like an engine on a vehicle or something. You know you always want it.
Yeah.
But
and then
this-
you can just boom, you don't have to spawn it. It's just there, it's attached. It'll move around with the object automatically.
Yep. And then spawn sound attached is a performant way of, you can create that component,
Yeah.
do what you need to it, and then when it stops,
Yep.
it's cleaned up and killed, and so you get your resource back.
So
Would
we
you
have
do
a
that with like footprint or footsteps on an animation?
That's a good question.
It depends on how you want to do it. Like if you can do play sounds and the steps will drop, but then as the player moves, they'll get
Yeah.
dropped behind the player. But if you want it to follow along with the
Right.
animating
So you're not
skeletal
replicating the
mesh,
sound
you
each time.
would spawn an audio component,
Yeah.
you would stay with the
Right.
skeletal mesh, and then when it's done, it would, yep.
And
Yeah, so that's a really good point. Like when you decide if you're going to use an audio component versus a regular play sound, is how fast things are moving.
right.
Like a gunshot, you might think like, oh, this is cool to just be a play sound. I don't need it to attach to the actor. But if you're moving really quickly, it might sound weird for the gunshot to
Gets behind you,
be
yeah.
trailing as you go through. Usually, audio spatialization in normal panning isn't high res enough to notice, but with VR and like
Right.
HRTF, which is a whole thing I'll talk about in a second, spatialization resolution can get high enough where you start noticing these things that in traditional games you can get away with more fuzzy spatialization issues.
Right.
But
Because you
anyways,
don't have a real perception of that space.
yeah, I could probably literally talk for about 20 hours on audio and blueprints, but I just kind of wanted to
I could do
briefly introduce people to like, how do I play audio and blueprints, and what does it mean, and
Yep.
what is an audio component? These are sort of just basic questions. So I want to get to more exciting stuff. So one of the finding stuff is concurrency. This is something it's kind of confusing. It's a really important thing for your game mix. I would call this polyphony, not concurrency, but when I came here, there was already sort of this idea of concurrency, so I kind of just made the feature a little bit more robust. It still needs a lot of work. We have some ideas on how to make concurrency even more powerful. But the basic idea is that it's a way to limit different sounds mutually. So like you can say these sounds that are together only play like 5 of them
Okay.
total. Even though we might have like, 30, 40 different sounds that could play, we want to say like, actually these footsteps don't flood all the sounds that are possible. Let's just play like total of 5 or 6 footsteps and let, a handful of guns, they kind of, so you can kind of carve out what I would call polyphony space for the different types of sounds that you want, and it helps you figure out your mix. Like one of the biggest problems, I'd say this, one of the biggest problems in game audio is mixing. I would say hands down, figuring out, and by mixing I mean that sort of broadly, because it can mean something literally in audio engine programming. It's like, adding sounds together
Right.
is mixing. But in the aesthetic sense, it means like what's important, what is the most important thing in the scene? How is that defined? How do we carve that out? You can't play all audio,
Right.
both for performance reasons, but also for like literal mathematical reasons. You have a limited amount of bit depth, which is like how much, just like graphics, you can't render everything. It just would blow out.
Right.
And Battle Royale is a perfect example.
Yeah.
100 players all shooting guns, so
Yeah.
you need to prioritize the scenes.
Exactly. So you got to figure out. So, anyways, concurrency is a really powerful tool in that regard. So I have a demo here to kind of show off what it means. So I built since we talked about blueprint, here's a slightly more complicated blueprint, not too much more from what I did before. Let me expand this out a bit. So you can see that when this guy plays, he just does a set timer by event. He chooses, this one is randomly picking a different, duration. And then here I'm just playing a play sound at location, randomly choosing from one of these cues to sort of demonstrate that it's mutually exclusive between different cues.
Yep, Aaron made an array there.
Yeah, so this is an array of cues, and then I just drop down different cues here. And then I'm randomly picking from that. This is how you sort of get 0 in the max index here. And then from that, I randomly pick that and then choose from this array of cues one of the values, and I feed that into this play sound at location. So this is another example of playing audio in Blueprint. So when I go into the world here, it'll play a lot of sounds. I'm actually meant to reset this back to.
Okay.
So so there's a
It's filling up all available channels.
yeah.
Yep.
So there's a debug command here that shows you all the sounds that are playing. It's stat sound waves.
Or stat sound cues.
Or stat sound
Or
cues.
sound waves. And so, yeah.
Yeah, I like stat sound waves to show you, because this is when I
real-
talk about
yeah.
engine architecture, it's the closest way to show you what's actually playing audio. So anyways, you'll see this kind of filling up and it's just chaotic. Right? So you want to, and keep in mind the 3 different sound cues. So I want to actually say these 3 sound cues, only play 3 or 4 of them at once, versus allowing it to spam your channel counts. So the way you set that up is on your sound cues. There's different ways of setting it up.
Sorry, headphone users.
Yeah, sorry. So basically, there's a slot down here for concurrency, and I just basically grabbed that concurrency asset and slotted it in. So when you do that, and all these guys are using the same concurrency group, like that guy, demo concurrency is what I called it. But anyways, they all use that. So now they're all added to this group. In the actual code, it's literally treated like a dictionary where I'm tracking the number of instances, and I use the asset itself as kind of like a handle to that group index. And so when a sound plays, it registers with it, and then it keeps track of it. And then to resolve the concurrency, basically, or resolve the polyphony, you choose a sort of rule, and that's what this asset kind of helps you do. So you first define the max number of things in that group. So I set it to 32 just now so you can hear the.
But you
sort
would
of
never
chaos.
actually use 32.
You could if you wanted.
Sure.
We default the total output channels to 32, but there are games that have shipped in UE4 with like 200 channel count and stuff. I don't recommend it because it starts getting heavy on the CPU. I think we use the default in Fortnite, right? It's just 32 sounds. We cut it. We reduce it on certain platforms to reduce the audio overhead. So it's a very easy knob to reduce CPU
Gotcha.
cost. So like on iOS, it's like 16, I think. We've cut it down in 16. But anyways, so let's just hear what it sounds like on 4, and then down here you have resolution rule to like prevent new. These are just sort of like enumerations of like how to, like if I have too many of sounds of this type in this group, what do I do? Prevent new will like force the sounds that are currently in the group to finish before allowing a new sound to play. This one I have is stop lowest priority, which is kind of cool. Stop oldest will allow new ones to come in but it'll stop the previous. So let's first demo stop oldest, so you can hear, you know. I mean, it's still chaotic because I'm just triggering a whole bunch of sounds, but you can see that, you know, in the stat, you can see that only 4 are ever playing.
Right. In that whole stack, only
Yeah.
those 4 are ever going to play.
And you can hear it stopping the previous sounds. So I added a new feature. It's not out yet in 4.19 for the new audio engine, where it actually applies a tiny fade out on stopping, which I call like a stopping voice. And
Would
I
you
kind
be
of
able to adjust that?
the fade out is basically for optimization reasons through the lowest level audio render buffer, just to like avoid doing like you know, if checks and stuff. But basically just does a fade out on one buffer, and so you don't hear pops or clicks from stopping. It's a really cool
So
adjustment.
it's lowering the volume and then picking up on the next audio file.
Basically, when you stop it, it doesn't instantly stop it, because you
Okay.
can hear that in audio. If you have a signal going, like if you have a sine wave,
Right.
it's very easy. If you instantly stop it, you'll hear an
You hear the
instantaneous
drop-off,
change,
right.
and that sounds like a click.
Yeah, it depends
Gotcha.
on the, unless it's at a 0 crossing, the
Yeah,
waveform will pop. You'll
exactly.
Hear it, so.
Okay.
And so this is basically prevents. It's like a little whoop,
So
little
it's
fade
slowly
out.
going under
Yeah.
that curve.
Yeah.
I got it. And then
So it makes the concurrency resolution sound a little.
does that
better.
second file start before it reaches the?
Yes,
its
the
conclusion?
new sound. So it's you know, there's some
you kinda
overhead.
have this.
Yeah, exactly. So the new sound's starting right away,
Okay.
while the other one's slightly fading out.
Okay.
Yeah.
Yep, makes it very
So there's a
nice.
little bit of time where there could be a little bit of overlap on stopping.
But it's going to be
sounds.
so minimal you won't.
Yeah, it is. It is complicated in terms of code to deal with that, but it sounds great.
Yeah, it's more common to how DAWs and other things work too. Like that, they'll do
Yeah.
that to prevent clips.
So I just to demo a different one is I have stop lowest priority. So the priority on that is defined on the sound cue over here. I'll just show you where that is, and you can see over here. So I got to sing while I do it. Do, 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 do. So here, there's this priority value here. I think this guy's 10. So I went and set them to different priorities. I think this guy was the one that was the highest priority. Oh, no, this is the lowest.
Okay, so that was going to be my question. Is priority set on a 1 being highest or 10 being highest?
One is it goes between 0 and 100.
Okay.
There was a limit. I'm not going to get into it, but there is a reason why there's a limit.
Right.
But basically 0 to 100, and it's float, so it's essentially almost
Okay, so-
infinite. You know,
And
it's not really infinite, but
And it's ad hoc, like however you set it up and
Yeah.
decide to use it.
It's up to you how you want to define what your priority ranges are. So anyways, so here it's only I think probably big step cue will always win if it plays, so you'll hear that.
Yep,
So you can see your
definitely-
big step is just always playing.
Yep, it's the highest priority.
This is the highest priority.
Yeah.
It wins.
Yeah, not that this sounded good. It just shows, it's like a toy example to show
Right.
concurrency. All
But
right,
that,
so
if your priority was 1 and the next one was 1.1 or 1.01,
it would still work, yeah.
win.
So caveat on that is that I do as a default final concurrency thing. I'm tempted here. I have this audio engine architecture diagram.
We got it.
I probably just not
Look
to
at
get
this
into it.
graph.
Yeah, I know.
It's like-
Not to get into it too much, but there's this sort that happens here. So we have this sort of game audio event. I'll just talk about it. It's an audio architecture talk, right? So we'll just quickly go
Yeah.
through it. So game audio event happens. In the engine, we have this thing called an active sound, which is sort of a container of random data. Not random data, but data that you might want to play sound. We're talking about concurrency right now. That's evaluated right away before we get into the audio engine, because concurrency is used not only as a tool for sound design in terms of like carving out your stuff, it's actually also an optimization. So like if you can prune out things that are going to play sound up front, then you don't have to spend any CPU time evaluating them.
Yep.
It has some limitations though. This is something a lot of people get mixed up on.
Yeah, but this is the only way we can do things like Fortnite on iOS, which
Yes.
is like coming down from a PS4. so-
Yeah. So we prune a ton of audio using concurrency before it even gets in. Because those sound cues that we showed you are really powerful, they actually get evaluated every audio thread tick. So if you have like thousands of sound cues trying to play, even if they're never going to play any sound, they still might cost CPU cost. And so there's other optimizations that have been made to call based on distance and all these other kinds of things. But one of the ways that we can call is using concurrency. So anyways, now we have this active sound list of things that have survived concurrency, and then every tick in the audio thread we update for every active sound. We evaluate the sound cue graph, if the sound cue graph exists. Otherwise, we just go straight here if we're just playing a sound wave. That's when I first demoed it early on. And then we have this giant list of wave instances. This could be 500 elements long. So when I went back over to here, this stat sound waves, active sound waves, that is this list here. And we can't play 500 sounds that are trying to play from every sound cue. So what we do is, from this list, we sort it based on, this is why this is important, the priority value that I just told you about, that you set that priority value, and its volume. So I scale the volume. That's what this volume weighted thing here is, volume weighted. So I take the final volume of that sound, accounting for all gain stages, including attenuation, random volume, volumes that might have been set in sound cues or sound classes, all that stuff. I multiply it by its priority, then I sort it, and then the ones that are at the top of that list are the ones that actually make sound. And so this is a really crucial thing for sound designers to have in their mind when they're trying to figure things out. And then this conversion to sound sources. So we turn from a sound wave instance, which is like it's like similar to active sounds, except it's like the actual sound parameters that are going to try to play audio. Active sounds are is potential sounds. This is the things that are trying to play sound. And then finally it turns into a sound source.
Okay.
Is a thing that's getting rendered in the audio engine. And then when I put it to that, then I go to here. It's got a mixer source, and then this is the new audio engine. So I'm not going to talk about this, but this is the point at which the new audio engine is all of what it means to be a source. How does it get rendered? And there's a whole thing. This is on the advanced side. We'll talk about this in a second.
Where does it go after it gets
Yeah.
I was
This is
actually
actually
wondering
a good segue.
if we could share this PDF with them later.
Oh, yeah, absolutely, 100%. Put it on that forum. Yeah. I need to send this to the docs team. I made this for Unreal Fest, and I showed it to one of our docs people, and they're like, "Whoa! Why haven't you showed this to me before?"
That's pretty awesome.
It's
When people say they need a flow chart,
exactly.
Yep.
you've got a flow chart.
So one final thing of the basic list. Sorry, this is something that a lot of people it's a really huge topic in game audio here, but it's mixing. And so this is attempting to demonstrate sound classes quickly, and including passive mix modifiers. So ambitious. This is a very ambitious talk. So this is a huge feature in the audio engine. Basically, what I'm doing here is, I think this should work. I think I had this tested. And if I hit the 1 key, it's going to play a 2D. Actually, let me back up. First of all, there's this idea of a sound class. I'm trying to go quickly because I want to get to the exciting stuff.
This hasn't been exciting?
Oh, this is all boring.
Inverse square
this is
was
the boring
exciting. You
stuff.
had me there.
This folder is more advanced features. That's the exciting stuff. But anyways, so we have this idea of a sound class. So let me just show you a vanilla sound class. If you make a new thing here, it's called a sound class. And what a sound class is a way for you to group different sounds together in a kind of a classification. That's why it's called sound class. But the point is that the problem it's trying to solve is you have hundreds of different sounds all set up everywhere, and I want to turn all of them down together. I could go and edit each of them manually, or I could have them all be in a particular classification and then turn it down in one spot. So that's the sort of, at the base level, that's what sound classes are doing. And so I have multiple sound, let's see, where is, like this guy. So if I go like this, he's on demo sound class. Let's go to that guy. I keep using the word guy, I apologize. But so demo sound class here is him. And if I go here 0.2, you'll see that the volume of that sound when I play it, if I save it, is going to be quieter. And this could be many, many, many hundreds of different assets, and they would all be quieter. And I can also make it louder. So we do allow you to go above 1.0. So go back to that guy. So it's louder. Also, this is, I think, a critical flaw in design on this is that we have lots of other things that can be affected as a group. So you get this thing where it's a kind of grab bag of lots of different parameters. So we can also, for example, change the pitch on tons of different sounds all at once. I don't really know why you'd want to do that, but you can do that.
The only reason we ever use that was on sound mixes that do special effects for slow motion. So it goes ew.
Yeah. So I added a global thing, but yeah, that's
the only reason.
Yeah, so you can hear it pitch down.
Yep, super low pitch.
Yeah.
That was creepy.
Yeah.
But anyways, there's a whole bunch of other features. We can't get some of these are defunct. Like again, we have a history of things. This radio filter does still work apparently. There's some licensees that have said that they're shipping with it, so I haven't deleted it yet.
Simple wave shaper, yeah. But
yeah. So this is a radio filter that
sound
was
like you're on the radio.
Yep, it will basically apply a very simple wave shaping
Yeah.
effect. It sort of sounds like you're coming over radio.
Yeah,
So,
like back in the olden days in Gears of War, there was a radio filter kind of a thing that was created and has now lived in UE4 forever. And they didn't have a flexible architecture to like make a plugin to make an effect like the new stuff does. So this is sort of like a strange legacy feature. But there's lots of stuff in UE4,
That's
not
cool.
just in audio.
So like that video that we showed in the beginning, the watch or the with the lighthouse, that guy had the audio thing in there, and it sounded like a radio.
That
playing,
could
so
well
they
that could be
all
done
could've-
with a new audio engine with like which
Okay.
I'll talk about. So they could be using this, but I hope not.
yeah. The general idea was that you could take radio, VO that didn't sound like it had a radio on
Yeah.
it, like plain old VO,
Yeah.
and then turn the radio effect on
Yeah,
over
it's a
distance.
procedural radio
Gotcha.
effect.
So if you move to another room, it'll
Yeah.
sound like he's in the room.
Typically, sound designers will hand
Yeah.
author radio effects. The reason why you would do a real-time process is you don't want to have duplicate assets. So, like in Gears of War, they would have dialogue for, like, what's one of their Phoenix,
Yeah.
whatever.
Marcus Phoenix?
Yeah, Marcus Phoenix, and he would be like, "Hey, what's up?" But then like you walk away, and they want to make it sound like he's talking to you on radio. One way to do that is to duplicate it and have double the amount of audio, double the amount of processing,
Got it.
double the amount of
So
memory.
as soon as you walk away,
Yeah, so procedural radio processing
Got
would be
it.
like, and it would process it dynamically. That's one of the reasons why procedural audio is a thing. It's a huge topic. You guys, I think, if I recall, ended up just duping everything, right, for radio processing?
No, Gears actually
Did you
use
actually
this.
use it?
Use this
Okay.
for squad chatter.
So anyways, that's why you would use it. And that's why real-time processing and effects are very powerful, why the new audio engine is exciting, because it explodes the possibility for
Right.
procedural audio effects. So anyways, one of the things that the sound class thing is great at is this issue of ducking. So like when one sound happens, we want to reduce the sounds of other things. So that the highest priority sounds, again, about to mix, like a gunshot happens, an explosion, a grenade happens, and we
Right.
have like all this ambience going on, we want to reduce that ambience when that grenade goes off. So it's like, and the ambience goes away, and then it comes back, right? That's sort of the idea of ducking. It's used all the time in audio, in game audio, but also in audio and film and linear media, and it's a way for you to trick somebody into thinking something's louder than it is, which is the goal of HDR graphics, right? Like
Right.
you want to have, like when you walk in, you get blinded by the light, and then you get normal, kind of a thing. It's sort of like that with audio, where you go, you've normalized in your mind the volume of the ambience, and then a grenade goes off, but that gets quiet, right? In reality, it
Right.
does too. Like when you go outside and a grenade were to go off right next to you, you would just hear that grenade.
for a second,
Like for a second, and your ears would ring, but that's a separate thing. But the point is,
besides
your ears,
dying, yeah.
yeah, your ears adjust, your brain adjusts,
Ears and brain mask
Right.
out.
mask out quiet sounds when loud sounds are nearby. That's why you have to shout, in a party, because
So it's like a
all the
full-
noises masking themselves
Like a
out.
sonic, like a, what do you call it? Like a flashbang or something. It makes that
Absolutely,
high.
yeah.
Okay.
So anyways, we have limited bit depth, which means we have limited dynamic range in an audio engine. So we have to come up with mechanisms to emulate that psychoacoustic effect of masking, and that's sort of what this whole thing is. So this demo is hopefully going to work. So I have this sort of background substrate here, which is like an ambient starship. Imagine this is just an ambience, and then hopefully one key will work. So basically what I did was I hooked it up so that when this sound plays, it applies what's called a mix, which I'll show in a second, and it will reduce the background. So you can hear it go, poof, poof. It's a,
And if you start sound mixes, you can.
yeah, you can actually see. So we have, let me turn off stat sound waves. So now we just are like sort of debugging the mixes. You can see this passive demo mix gets applied.
You can see how fast it happens as well.
Yeah,
So
and it's very quick.
it's got the time to fade in and out. Which
Yep.
Oh wow.
And so this is sort of basic / advanced to hook this up, but the essential way to do it is you create this thing called a passive sound modifier, and you say when this mix gets triggered, apply a modification to this sound class. So I made another class called a duck class, and I said set the volume of this class. Remember I told you classes are a way for you to take all the different sounds and apply volume together. And so this could be like a whole bunch of different sounds, like ambience in
Right.
general. That could be your sound class.
The sound of
Ambience.
the nature.
Yeah.
Yeah.
And then say volume adjust down to 0.1, and then there's like initial delay, fade in time. I set the fade in time to 0. You can set the duration for how long you want the thing to apply. You can set it to -1 if you want it to last for the whole duration of the sound that triggers this.
So if it's something like, let's say, a jet flying overhead,
Yeah.
and you have this quiet, quiet, really loud, really loud, really loud, starts getting more quiet. Is that where you would use?
No, that would just be attenuation.
Well, but here's
Oh,
what
that's
you
fair.
could, here's
But I
what you
mean, what about the ambient noise around
well,
you?
well, here's what you could do is there's a threshold
Yes. Oh,
on the
right.
passive sound mix.
Yep.
So basically, the threshold at how loud do you want this mix to be applied? So the jet, while it's quiet, wouldn't trigger it, and then you have a threshold of say like half the maximum volume of the jet, and once that gets crossed, boom, the mix starts, and then
Right.
makes the background
So
ambience
then
come
your
down.
ambience comes down.
And then the jet sounds loud.
So, okay. So I need to get to the exciting stuff quickly. I only have like 25 minutes. All right. So there's so much depth here. It's exciting. But what he's talking about is down here, which is when you have a like a sound trigger, you basically say, hey, when a sound plays on this class, trigger this mix. That's how you hook it up. So basically, a sound happens, plays on demo sound class. When that happens, play this mix. That's the whole concept of this passive mix. And he's saying right here is you could set up a minimum volume threshold so that the sound has to be above a certain value to
Yeah,
trigger.
and so 0 means always do
Yep.
it.
All right, so there's a lot more. Again, this is another topic which could be 7 hours long.
Yep, we use this all over the place in Fortnite as well.
Yeah. So let me get to sort of more exciting stuff. This is sort of new DSP exciting features, with including binaural audio. So first, I want to show off this reverb. It's not really an advanced feature, but I'm proud of it. It's a reverb algorithm I wrote, and it's cool.
It's a lot better than the old reverb, which
Yeah,
is like a
and
lot
it's
better.
multi-platform.
Yep.
So I have this. So this is like a robot voice playing randomly, and so basically the way you hook it up is you create an audio volume, which is this guy around here, and from the audio volume, and it's just over here in the volume list, volumes, audio volume, and then you set up over here a reverb preset. You just right click, sounds, reverb, make a reverb effect, drag that guy over to here, and then say apply reverb, and now you've got reverb for sounds in this world. A new feature I added is the ability to do dynamic dry wet level sends using attenuation settings. And so in that sound I was playing, I'm using this attenuation settings. And you have this attenuation reverb send checkbox. And you can actually dynamically blend how much audio gets sent to reverb based on the distance of that sound to the listener.
It mimics the natural world much better,
Yeah.
for sure.
So you can actually, let's make it a little bit more severe so you can see it. Whoops, 1500. You can make it sound way more reverberant the further away something gets, which again emulates sort of how sound diffracts through the environment. So, and then what's cool is that all of the new DSP stuff is actually, so you can see it's very reverberant. So I can actually affect the reverb effects in real time here. So I can actually, you can hear it change. So I can make it a shorter reverb.
Yep, and actually while Aaron's doing this is one thing I wanted to bring up. This is one of the super, super powerful things about UE4 is that everything we've looked at except for blueprints,
Yeah,
you can manipulate in real time while Pi is running.
yeah,
So sound cue settings, anything in there.
yeah.
You can re-import sounds while Pi
Yeah.
is running. You can change sound class and
Yeah.
mix while Pi is running. So you can run around your game basically and iterate on the fly and
Yeah.
listen to it on the fly
Yeah.
instead of having to go back and forth. So it's instant. So we use that all the time on Fortnite, and that's one of the reasons we can move so fast on Battle Royale is that we can just boot up the game, try out a new thing in there. Hey, how does it sound in context with everything else? We can tune it very fast and turn it around in very fast time.
Yeah, so the goal in a lot of the stuff that we do, once you get good at the workflow, is to be able to work really quickly and efficiently. So I'm going to go on to the next thing here, which is source effects. This is a brand new and exciting feature set. So if I go here, sounds, source effect preset chain, this is just sort of how you set them up. So I'll say demo preset chain. So what this is, notice that, this is a new feature. I need to get icons for it. I still need to do that. It's on my list of things. So what this is a sort of an asset that allows you to contain other assets. And so what this is analogous to in your DAW is like your, channel effect
Insert in there.
inserts.
Yep.
And so I'm just going to add 2 effects for fun. Let's make a new one. Advanced features here, source effects. Let's do it. Let's go like demo source effect 1.
Just got a comment there.
Oh, do I?
Or period doesn't matter.
Oh.
Yeah, yep.
The screen I'm typing on is far away. I'm losing my vision. All right. So when I do this, you're presented with a sort of a class picker These are all of the existing source effects that I've implemented. We have lots of ideas for wacky ones. We want this to grow. Maybe even get subcategories in here for different types of things. This is all plugin extendable, so third parties can make plugins. People are doing some really cool stuff I've seen. But let's do a fun one. Ring modulator is always fun.
Yes.
By the way, I added one of your feature requests recently on it to do a dry wet blend.
Oh,
and
fantastic.
It's awesome.
That's great.
So let's make a new one here. And source effects. Okay, so let's do demo 2. Let's just pick another one. I think delays are always fun.
Yes.
Let's do a stereo delay. All right, so what's cool about these, so now that I've added these effects, I can very easily hook them up to any particular sound. Just, again, this is on the sound base class. So down here in this new category section in the new audio engine, you'll see demo preset chain. And I can just drag that on. And that should be all that you need to do to set up source effects. So when I play this, so let me...
Push the volume maybe. Or...
Yeah, let's increase the volume. Max it out. I think it only goes up to 4 anyways. But so you hear the delay on that? So what I can do with these effects is actually process them in real time. So let's do the...
Oh my.
So you can do delay line effects like pitch shifting and things like that with the delay line.
So all of these can be done. I didn't build a blueprint to show it off, but these can be parameterized in Blueprint, driven totally from Blueprint, based off gameplay parameters and effects. So the other effect that we have is this guy. So this would be the ring modulator.
A lot of the Star Wars droid sounds
Yeah.
for voices are made with this.
Yeah, exactly. You know, so anyways, source effects are really cool. You notice I was playing that in the content browser and modifying it real time in the content browser. The same could be done if this was in the world. We could be messing with it in real time. So submix effects are a whole other thing. So submixes, I'll just briefly talk about it. It's more of an advanced thing that I'm going to cut because I don't think we're running out of time. But the idea is that you create these submixes. Submixes are actual DSP mixes where multiple sources would get mixed together, and then from that get sent a effect chain.
Yep.
And so
it's important the sound classes are just logically based.
yeah, sound classes aren't actual DSP buses. They're just like logic parameter maps. And so I think actually I just set this up. So what this is doing is running a lot of audio. Hopefully I'm not clipping. But anyways, this is running a lot of different sounds through the same submix and then applying this dynamics processor. So this is actually a compressor, like making things really loud intentionally. But like, for example, you can reduce this to like, you can see that it's working here. So you know, dynamics process, if you're an audio person, you'll know that like noise stuff gets boosted up a lot. Quiet things get louder. So you can see when I, increase the gain here on the output and sort of, let's see, the ratio here, make it really crunchy.
It's basically a way to control, as things get
yeah.
louder, how much to turn them down by.
Yeah.
Sounds like a robot going through a forest.
Yeah, exactly. All right, so the last thing I want to show, 2 more things, binaural audio and synthesis. So this thing, I made a really cool, like, demo of real-time synthesis. I could have just spent the whole hour on this probably. But what this is a whole exciting new direction that we're taking the audio engine, which is real-time synthesis. So what this is over here is a modular synthesizer that I just added. You go to add component, synth. Also really quickly, you have to enable a plugin. All those effects and the synthesis is inside this plugin. This is a plugin I made, and that's my programmer art that I expected somebody to complain about, but nobody
What are
has.
you talking about? That's
Isn't that great?
Picasso level.
Yeah,
That's
that's
right.
amazing. It's
Picasso
additive
waveform.
square wave.
Yep.
So anyways, what this is doing is actually just playing the synthesizer. We don't have time to go into depth, which is sad. Maybe I can do this again with just synthesis. But if you see over here in the left here is a synth preset. And you can see, if you're a synth fanatic, you can see all of the parameters of a sort of Moog-like, subtractive synthesizer. There's 2 oscillator types, full parameterization. I've implemented sine, saw, triangle, square, and noise sources. They're all kind of attempted virtual analog-y kind of stuff, so they're not like wavetable based, they're actual real-time generated waveforms. And then I implemented a...
So you can make 80s music in here.
yeah,
That's what
totally.
you
You can make it... I mean, that's one direction you could go.
You don't want to make One Direction.
So anyways, you can also switch out the filter algorithm. You could do a one-pole filter, state variable, or a ladder filter. Ladder filter is the
Yeah, the classic.
classic, yeah, which sounds great. You can switch out the filter, low pass, high pass, band pass. Anyways, so there's a lot of power in all of this that you can play with. I recommend doing it this way to make a preset as a variable because you get this nice detail panels. If you do this, make synth preset, you'll get something that is insane in Blueprints.
Yeah, you won't.
Oh, why?
You won't like it.
Whoa.
So I recommend, I mean, people are doing stuff like that. I don't recommend that path. You can also, the synth has a whole bunch of setters on every parameter. So if you do like set filter frequency, every single parameter has a setter. So you can hook this up to something like a timeline and then like do parameter modulation straight from here. So you could have like your game thread going like,
Right.
you know, kind of a thing. So while you could imagine an event happens and you want a real-time synthesizer to dynamically process it based off of whatever gameplay parameter you could possibly think of, this is super powerful. I totally recommend going in that direction. I made a little demo here just to show you it working. It plays like a really cheesy, random melody.
That's all randomly generated.
Totally. So if you do it each time, it's random. So procedural music is entirely possible in Blueprints. So Dan Reynolds is my technical sound designer that works with me a lot on engine features. Is a genius in procedural audio, and it would be cool if he gave sort of a more in-depth sort of like how to do
we had him
procedural.
on
You had him on like for
the building and
stitching
audio
music
and-
stuff.
yeah.
But anyways, this is a very powerful thing. I highly recommend getting into it.
Yep, and the granulator variant of the synthesizer
Oh,
is
yeah.
super awesome for sound design.
Yeah. There's
very similar.
We
setup,
have
yeah.
that's a good point. We have a couple synths that we've implemented. Also, again, this is all in a plugin. So if you're into synthesis, you can make your own. But we have like a granular synth in here. We've got a wavetable synth or a wave player. So anyways, if I type synth, I think it shows up. Yeah, synth sample player. So this guy lets you go reversing in files and sort of stuff like that. The last thing I wanted to show you is binaural spatialization. I can't believe I might actually get through all this. So there's a bunch of stuff that we have implemented for third-party plugins for spatialization. We have support for Steam Audio, Oculus Audio, Resonance. We also have on Sony PlayStation, we have A3D, and there's other third parties that are making more plugins. I chose for this demo to just set up quickly Google Resonance, which I particularly have enjoyed. So the way we've sort of been trying to solve the problem of how to wrangle all these different possible plugins on different platforms. And so right now you have to go to the platform settings and sort of set up your spatializer that you want. So right now down here on the Windows, it's set to do built-in spatialization, but let's set it to resonance and for reverb as well. And so with that, this map here is going to play a sound, and it's set up this binaural audio to do binaural spatialization. So now when I play this, theoretically, this should be, if you're listening at home on stereo, it should sound very well spatialized.
Yeah, on headphones, yeah.
So we're not listening on headphones, as you can tell, so hopefully this is working. Yeah, it sounds like it's spatialized. Does it sound really cool? You're over there with headphones. Does it sound really well spatialized? Yeah, so that's the magic of binaural audio. So yeah, that's how it works. There's a lot more details. Google Resonance has better, documentation set up than I've described, but we have HRTF plugin support.
Awesome. This is
I
incredible.
made it through everything.
You
Made it
did.
through.
Almost.
So now we have to get into this. So how much do I have? 30 seconds? We can go through this in 30 seconds. No, I'm just joking.
You have
This
to
is
sing the whole thing.
this is the new audio engine. This is how things get decoded, processed, synthesis. We have this thing called source buses I didn't mention, sample rate conversion, how all this stuff works. This is the submix graph. If you are an audio programmer wanting to get in, just check this out. Ask me questions.
Speaking of questions, do we have any questions?
Yeah.
from
You
Alex?
have lots of questions. We're going to keep, I probably won't get to all of them today. Is it all right? We'll go through some of them, but then can I toss this list
Sure.
your way?
Yeah, we
and
will follow
do
up.
a big like.
I
forum
can
post?
jump on the forums
All
and,
right.
answer questions.
So they're asking about official documentation. We're actually working on that, right?
Yeah,
We
so-
have written a lot.
So the docs team, there's a new docs system that we've been waiting on. We have like 50 pages on docs that we wrote like back in October that got put on hold, but now things are out of date, so we have to go through those 50 pages. We don't have time. It's this issue with docs. One of the reasons why we haven't posted docs on the new audio engine stuff yet is that we didn't want to have this weird quasi state of like, this only works in this new thing that you have to do, and then it's like a terrible thing.
Right.
The idea was that people that are early adopters of the new audio engine are adventurous anyways, and we have forums. I'm very active on forums. People out there, I answer questions a lot. We have UDN. A lot of people have asked questions on UDN, which is our Unreal Developer Network. So that's sort of been the strategy. I wouldn't almost call it a strategy. It's just been the way it has been. But we definitely recognize our docs are in a sorry state for a lot of this stuff,
Yep.
which is part of the reason why we're doing this, is to kind of be like, hey, here's some stuff. I know there's not a lot of docs. Hopefully this will get your
Right.
feet wet and you can kind of
Yep.
get going. And this could be a basis for
Just to
the
start.
docs team to even look at what
Yeah.
we're doing and go like, oh my God, we don't have docs on any of that. Let's get this guy. That's how it works. So apologies, and
It's-
we're trying
but
to be better.
But it's coming.
It's
coming.
well, yeah, that's the intention. We
Yeah.
don't want it to have no docs forever.
Do we have any plans for like capturing audio from the microphone on mobile?
Somebody just asked that on some other forum. I would say the answer. So the question is, do we have plans? The answer is almost never like, no, that's a bad idea. It's a great idea to support mic capture on mobile. The question is more about priority. In the near term, it's definitely not a priority, but it's something that we would like to have eventually.
Yeah, and I think it's also part of some of our VoIP plans and things like that to kind
Yeah.
of eventually look at that for sure.
Excellent. They're wondering about some of these audio assets. Like, would you be willing to release this project or these assets?
Yeah, these assets are freely shareable. They shipped with the Niagara demo that we did for last GDC, so they're ready
Okay.
to go, so we can
Yeah.
share these.
I mean, I could just save this and bundle it, even
Yep.
though it's literally improvised and kind of a mess. I wouldn't call this in any way a thing but I can just show this. If you guys,
Zip it up and
yeah,
share
yeah,
it.
you can just share it as is. You can, might be fun to look at how I did the procedural music synthesis stuff.
Yeah, I think that's a really cool.
Yeah.
Are there plans for interface customization options?
Yeah, so Ethan Geller is a new audio programmer, and I have been like brainstorming about ways of exposing interface design to third-party plugins, because we have this cool new DSP architecture, but there's this whole world of VST plugins which have ridiculous interfaces. It's possible with Slate to be able to expose that to a third party and actually have a VST as a audio plugin, widely adopted format that a lot of sound designers are used to.
Yeah.
So, and there's a whole constellation of VST manufacturers which are interested in UE4, and it would be cool if we could support custom
Yeah,
UI in a plugin. Like
Yeah,
that.
and it definitely supports having the UI and the workflow that people are used to with knobs and faders and things like
Yeah.
that. And also, it is hard to understand the relationships of things in a list, so
Yeah.
we're definitely looking at it. Very
Yeah,
much.
Yeah,
people
yeah.
were asking about knobs.
I've actually
Yeah,
made a knob. If you saw at GDC 2017, so where's it? I can just show you real quick user interface. So if I make a widget,
Or do you just
Slate,
like-
is it Slate widget? Is this the guy? Yeah.
Or blueprint version, or-
Yeah. So over here, if you enable the,
Oh, wait,
there's
was it
a
synth
knob
2D
in here.
Is it actually the synth 2D slider?
Yeah,
Nice.
that's it. So I
Oh,
made a
synth
synth knob.
Nice.
So there's already a knob. So if you wanna,
Behold.
this is.
The knob.
It's a little bit jank. This is what. Look at that. It looks totally jank. Anyways,
It's like a thumbstick that's broken.
Yeah.
yeah, I should probably fix that. But that's what Dan Reynolds used for the ridiculous synth interface that we made for GDC in 2017. That was entirely done in Slate, in
That's awesome.
UMG.
Yeah.
So it's possible. We want to do it so that you can do it in the editor, though, not just as a UMG
Yeah.
widget. Yeah.
Yep, so you don't have to play the game to use it.
Yeah, exactly.
Do we have access or do accept like MIDI controller input and things like that?
Yeah, we actually have a MIDI plugin as well. If you go to plugins, right now the MIDI plugin only does MIDI input, but we do have MIDI support. It's a little bit low level. Dan again built a really cool blueprint that uses it. We can find that and actually post it somewhere. People keep asking about
Should
it.
post it, yeah.
It's my intention to make the C++ code do all that work for you, but I just haven't had priority to clean up the MIDI plugin. But technically, we have MIDI input. We don't yet have MIDI file playback support. That's something that we would like to add.
Okay.
Like in other words, like import a MIDI file and then just be able to play it
Play
back.
music,
in
yeah.
Well, if not music, like have
Or
it as
events,
a blueprint,
yeah.
like event controller. It'd be great. Yeah.
Do we have planned for built-in occlusion? As
Oh,
opposed
I didn't
to-
talk about occlusion. It's one of the options here. If you see in the attenuation, so attenuation
So, yes.
occlusion. So we have occlusion. It's a very basic occlusion system. It's
Mm-hmm.
a single raycast. You can set up your own trace channels. Custom trace channels will show up here. As I was telling Zach about this recently in a
it's
very
basically the-
specific Fortnite issue that we were doing.
Yeah, but basic rules for like how it gets
Yeah.
evaluated.
These are like the things that get hit from the trace. But yeah, basically once it's hit as occlusion, it'll apply a
But you
filter
can
or
only do
volume
one
attention.
ray?
It's just one trace between source and listener.
Okay.
So if you have hundreds of sound players, that's hundreds
Right.
of traces. So it's a trace per sound. Its intention is to be as cheap as possible.
Okay.
Versus like the most robust occlusion system ever. Steam Audio as a plugin has a really advanced occlusion system, which does like fluid dynamic simulation, all this stuff. If you're looking for like ultra
echoes
realism,
and-
it'll just be expensive. You'll probably have trouble shipping it on anything other than high-end machines. But occlusion is a hot topic in audio, so we have it. But we're looking at ways of maybe making the existing thing a little bit more robust with potentially options on multiple traces and things like that.
Yep. And as long as we were talking about attenuation there, I was seeing in the settings too. If you guys haven't looked at it, the focus settings are really great.
I also didn't talk about focus.
That's okay. It's
We
a side thing,
switched
but it's
it.
yeah. But yeah, if you guys look into it, basically it's a way for if you're looking at something for it to either get louder or quieter when you're not looking at it, which is a lovely thing to have.
Yeah, that's
for-
this thing right here, listener focus.
Yep.
Yeah,
That's
this
right.
thing.
Yep.
Will you
Awesome.
point out where the occlusion
Oh yeah,
is?
sorry, no one was looking at it.
Yep.
The occlusion thing is
There
down
it is,
here in
yep.
this section.
Yep.
So you can see different trace channels over here,
Rules for that.
and then what happens when something's occluded, if it's a filtered or volume, that kind
Yep.
of thing.
And then the focus stuff, real quick, if you scroll up, if you just turn it on, the most
Yeah.
basic thing you can do is those are the angles for what you're looking at, so the minimum
Yeah.
and maximum, and then the thing that's most, I'll give you the most bang for the buck is non-focus volume attenuation, and
Yeah.
put that at 0.5. So if you're not looking at it, it'll be
Yeah.
half volume. If you're looking at it, it'll be full volume.
Oh, okay.
That's
And
really
you
cool.
play in
Basically, it's like a
between.
cone. So like, as the listener moves around, you can attenuate things outside of what you're looking at.
Got it.
Yep, so it's not taking up dynamic range
It's
if you're not looking at it.
remember with the idea of the prioritization scaled with volume.
Right.
It's another way of carving out what sounds actually play.
So it's helping refine that.
Yeah. So
Ambient
typically,
noise,
what I'm looking at is more important than things that I'm not looking at. So
Right.
that's a one way to.
You know, like a waterfall or something like
Yeah.
that. Yeah, so-
Gotcha.
All
That's
right.
awesome.
Well, I think we're going to wrap up
Yep.
for today. Thank
good.
you both so much for joining us.
Yeah, this was a lot of
It
fun.
was fun, thank you.
They
guys were
have
great.
tons. There are more questions that I'll share
Yeah,
with you all, and
please
we'll
do.
try
Cool.
to bounce that back. Audio is a hot topic and something that a lot of people have questions about
Yeah.
and are excited for.
This I kind of gave this kind of talk at Unreal Fest, and it seemed to go over well. I think people liked the demo, so hopefully it was useful for
Yeah,
people.
I enjoyed listening to it.
Well, it's
Yeah.
an important part of
Yeah.
the gaming and other experiences. If you have feedback for us, I've tossed the survey into the chats, so please fill that out. Let us know how we're doing, what topics you would like to see in the future. As always, check for local UE4 meetups in your area at meetup.com/pro/Unreal Engine. There's a lot of great content being developed and presented in your area, probably. Also, submit your projects to the NVIDIA Edge program. We like sending 1080 Ti's your way, so we pick 3 every month and send them out. So you got to let us know. You've seen the countdown, so
Yep.
Tim's driving that.
So if you guys want your countdown put on the stream, we're looking for speed development into a 5-minute timer. So if it's an hour, hour and a half, whatever, it needs to be an hour long. Please include your logo. Share that on the forums. Let us know you're doing it. Can't guarantee that it'll make it in, but we definitely love seeing those. We have Kindred Games right now with and Estomist, and they've been great, and we'd love to expand that. And make sure you guys follow us on social media on Twitter, Facebook, Instagram, here on Twitch. Last thing is many of you noticed at the bottom here it says that we're streaming to Unreal Engine. So Unreal Engine is listed as a game now. So make sure you follow the channel to check out any Unreal Engine developers. Or if you're streaming, make sure you stream under that, and we'll pop in from time to time.
All right. Thanks
All right.
again, guys.
Yeah,
Thanks,
and
guys.
we'll
It's been great.
See you next
Yeah.
week.
Take care.
Okay.